Hi, my name is Brooklyn Price. My co-presenters are Abigale Virto and Erin. Our coach is Dr. Vinodh Chellamuthu, and we will be presenting modeling the dependency of squirrels on the human population, which is our model that we've created to answer problem C. Almost every park you go to will have some type of sign warning against feeding the animals. These warning signs will often include what the side effects of feeding animals in an area are. These side effects range from the ability of the animals to scavenge being reduced to making them less likely to be able to avoid predators. We can see that humans moving into an area where animals are can have a major impact on the natural population of animals there. Our model aims to explore what happens when a human population is introduced to and interacts with a population, as well as what happens when they leave the population. We have chosen to focus our model on the eastern gray squirrel population. Squirrels are commonly seen in parks throughout the United States, and most Americans have had interactions with squirrels, whether they've been feeding the squirrels, they've read a sign about not feeding a squirrel, or they've seen somebody else feeding the squirrel. This makes it the perfect population to study. In order to make our model, we needed to have some parameters. Some parameters that we are interested in are the rate at which humans are being introduced into an area, and then the rate at which humans are leaving an area. We are also tracking the rate at which squirrels are being born into the population, as well as how quickly they are dying in the population. We also include parameters that are related to the amount of positive and negative interactions that the squirrels have with humans, and these rates influence how willing a squirrel is to become more dependent or less dependent on a human.
So before we get into our model, we have a few assumptions that we made. The first being that a positive interaction between a squirrel and human results in the squirrel getting food from the human. And then a negative interaction between the squirrel and a human does not always result in death, but it can result in the squirrel becoming less dependent on the humans. And then as squirrels become more dependent, they're more exposed to humans, thus their positive and negative interactions increase. So there's more squirrels in those categories to be able to interact with the humans. And then we also set the rate at which humans enter and leave the area based on what we want our model to show. There are a few key terms that are important to understanding our model. The first is the definition of our independent squirrels. These are the squirrels that don't receive any food from the humans. They only scavenge for their own food as a source of sustenance. The semi-reliant squirrels, they do both. They rely on the humans partly, and they also rely on their own food sources. These are like the in-between squirrels. And then the reliant squirrels, these are the ones that are completely reliant on the humans. They have moved all the way, and they're not scavenging for their own food. So this is a schematic diagram for our model. The focus here is at the bottom with the independent, semi-independent, and reliant squirrels. We have depicted the birth rate as alpha. The alpha on the humans is more of a humans entering the area where the squirrels are. And then we've also depicted the death rate as the squirrels leaving each population as beta. And then for humans, again, it's more of the humans are leaving the area. And then in between each population of squirrels, there's positive and negative interactions. The positive interactions are the P and R. They're moving towards the reliant squirrels. So humans are interacting with these squirrels and they're positive. So the squirrels trust the humans more and therefore they're moving to depend on them more and more for food. And then we also have the negative interactions, which are N and T, and those move backwards. They move back to being independent because they have had a negative interaction with humans, and so they don't trust them as much anymore, so they're moving back to being independent. And we've depicted the interaction with the humans as a dotted line rather than a solid line because it's more of they're not directly adding to the population, they're interacting with them and then making them move on to the next category.
These are the differential equations that represent the relationship and interactions between the humans and the different groups of squirrels, as we showed in this schematic diagram. Now we're going to go over some of the results of graphing these equations. This is the graph of our differential equations and our parameters from the original parameter table. As you can see, as the human population increases, the independent squirrel group quickly decreases, and the reliant squirrels increase at the same time. However, the reliant squirrel population never gets to be very high because the death rate of the reliant population is so much higher than the birth rate. So we adjusted our parameters to see what would happen if our birth rates were higher than our death rates. We adjusted our rates so that our death rates were not as high as they were before, so that there wasn't as big of a difference between the birth rates and the death rates. In this graph, you can see that the human population increases the same amount, and the independent squirrels quickly decrease, while at the same time the reliant squirrels quickly increase. It's also important to point out that the reliant squirrels are dying off faster after about day 225, and this is because their death rate is higher than the semi-reliant squirrels and the independent squirrels. And this is based off of our assumption that reliant squirrels would die more because of their lack of ability to provide for themselves, and their senses that would previously keep them out of danger are decreasing.
We ran a simulation where the death rates were significantly higher than the birth rates. As you would expect, the population of squirrels eventually dies off because there are not enough squirrels being born into the population to replace the squirrels that are dying. But one interesting thing that you can see is when we chart the deaths by each group of squirrel, the reliant squirrels have the greatest impact. And we would assume that the reliant squirrels are dying off quicker or at a greater amount in the middle of our simulation because they are more reliant on humans, and so they are more likely to risk being attacked by a predator, and they have lost some of those behaviors. And so this shows that the squirrels that are reliant are more likely to have a higher death rate. Towards the end of our simulation, everything evens out, but we found it interesting that in the middle of our simulation, the reliant squirrels have the highest death rate and the most impact. For this simulation, we changed the positive and negative interaction rates for the squirrels. So we increased the positive interactions and we made the negative interactions half of the rate that the positive interactions were. This means that the squirrels are twice as likely to have a positive interaction than a negative interaction. We can see that when they are having more positive interactions and negative interactions, the squirrels will leave the independent group and become a part of the reliant group. And at the end of our simulation, the population with the most amount of squirrels in it is the reliant group. For this simulation, we switched the rates. So now the squirrels are having 2 times as many negative interactions to positive interactions. And so the positive interaction rate is half the negative interaction rate. And we can see in this simulation that the independent squirrel population just keeps growing and it stays relatively high. And this just shows that the squirrels, when they are having these bad interactions with humans, they're staying away and they are becoming reliant on them. So they aren't losing their ability to scavenge for food and they aren't losing their ability to be wary of predators. So they are just staying independent and it's protecting their population.
So this graph depicts the humans leaving the area. So we have removed the humans. We're making the beta for humans greater than alpha for humans. And here you can see that the green line, which is the reliant squirrels, they have a really sharp decrease. They move from about 800 down to less than 200 very quickly, and which is to be expected because they depend on the humans the most for their food, so they're dying at a quicker rate now. As compared to the independent squirrels, they did not decrease quite as steeply, which is what should be expected. There are a few key takeaways from our model. The first and foremost, just don't feed the squirrels because they become reliant on humans and they suffer greatly, as shown previously when humans leave the area. And almost every simulation that we ran, the majority of the squirrels were shown to become reliant on humans. It happens pretty quickly. And then their dependence on humans can reduce the squirrel's ability to find their own food, which results in higher death rates and starvation. So there are a few key strengths with our model. One being that our parameters are very adaptable. We could increase the rate at which humans are moving into the population. Maybe the population we're studying they have more humans, or maybe they have more squirrels. And so we could change those things based on whatever we're studying. It also considers the effect that different types of interactions have on the animal population. For example, our positive and negative interactions. One weakness that we found were that the human interaction rates are estimated to the best of our knowledge just based on the research we found on domesticating squirrels.
There are multiple things that would have been great to add to this project, but we couldn't due to the lack of time. So some of the future work that we would like to do is refine our parameter values. One of the most challenging things of this project was finding accurate parameter values that would also fit with our model. Another thing we would like to do is introduce a population to explore the interaction between the predators, prey, and the humans, and how all of those groups affect the squirrels. We would also like to expand the model to run over a longer period of time so that we could see more long-term results. Finally, we would like to acknowledge SIMIODE and thank them for putting on this competition and giving us this opportunity to work on this project. We would also like to acknowledge and thank our coach, Dr. Vinodh Chellamuthu, for all of his support throughout this competition.